What's good, everybody? It's your boy Joe. Well, we're gonna be getting into pretty much the same thing. We're gonna be creating like a going to be creating a to kind of incorporate what we've been doing here. We're gonna create an ISB. That didn't work out. So bring this over here. We're gonna create an ISB. We're going to create an ISP, an internet service provider network. And that network, network's public address is going to be very simple. 192.1.0.0, and they're going to have a, we'll say, they have a class. We want them to have. I'm gonna do this. Yeah, it's a class A, so they're gonna have. How many addresses is that? It's pretty much going to be just 32 bits, which is only 8, 8, 16, 16. So /8. So we're gonna go back here. There's this too. All right. So the internet service provider today, their public network is going to be the 192. I should change that. Let's change that to something else, so it doesn't get confused if we use that, like the 192.168. So let's change that to something we really wouldn't see. Probably. That's something unique. So we'll say 66. Yeah, that's unique enough. So the 66 Class A network. So the internet service provider will have the full range of these 3 octaves here to create publicly facing reachable addresses. So we're going to utilize those addresses to build out this network, and we're going to kind of organize it about, and then we're going to branch off to like cities, say like 3 of the largest cities: Boston, Dallas, and New York. So Boston, Dallas, and New York. We'll create branches for each one of those districts, geological districts that branch off of the internet service provider's greater network. But inside of that, we're going, so that's going to be the greater when we get down to smaller, but we're going to build redundancy in a backbone network using layer 3 switches as our backbone network, with ether channels to load balance traffic between the three districts here. So that's the plan. We'll see how long I stream for today. I'm gonna just go check here for a second just to make sure the stream and everything is looking good, and actually Sounding okay. Yeah, everything sounds good. Music volume's not that high. Yeah, if that music volume's too high, guys, just give me a shout, but I think it's pretty low. You guys can barely hearable. Good enough for me. It's good enough for me, it's good enough for you, right? What else we got here? Oh, I did build this today, so I built a little get this out of here real quick. And y'all can't even see it. Alright, so we'll just use this as a small window. But just enough to help us. So I built a little IP address calculator today. Just so when we are branching off these, when we're breaking apart our network and divvying up our interfaces here, we're keeping everything in lockstep here, so we're not stumbling over our addresses and whatnot, our subnets, and messing everything up and stuff. So for the most part, I think I'm gonna keep everything to like a let's see, so that's to probably like a is that 28 slash 28 245 245.248. Gives me about 6 addresses per. Let me just try something like that. One, say 10.1, and we're gonna give that a 28. It's 14. It's 2, so it's a 29 mask. I'm gonna say 66.1.10.1. 29 masks. Yeah, so that's 6. So we'll use the 29 mask as we break apart. Yeah, as we break it apart. That way we have a usable, if any case, we always have at least so it'd be 2 minus from that. So we'll always have at least 4 available other possible addresses within that subnet range if we ever have to hook up extra redundant links and whatnot to the topology. But you'll get a sense of what I'm doing. If any questions or anything like that comes along, and I believe if you guys are curious on how I built and deployed this simple IP address calculator, I believe I put it up on my GitHub page today, but it's just a simple Docker container that's running off of one of my other servers I got running. That's all that is. But yeah, it works pretty well. It's pretty simple, one would say, like me, simple. But all right, so we're gonna use this again, and we have our notepad here. Going to label this our new network here so we don't forget 660.0.0 is our network. And that's a Class A network. And we'll label this SB ISB1's network. What is it? Control plus. That's it. You guys can see that a little bit. Next. No. All right, so that, get to that in a second. That in a second. Here is our first multi-layer switch here. So it's that. As you guys can see. SB. And we're gonna name this ISB. One. -1. BB dash dash. Let me save this project. Actually, let's name this stream. What's today's date? 16 May, 16 May 25 project. We're gonna add. We gotta add some power supplies to this, and not power covers, power supplies. That makes. That's turning on. Cool. Alright, we'll give that a second to turn on. We're gonna come over here. So if we're gonna start thinking about our addressing, it's all set. I can erase that now. All right, so I'm thinking for our backbone, we'll have. Yeah. Right. understand in a second. I'm trying to do, yeah. So that would need 3. Yeah. Change this color. One, two, three. So one would be connected to each other. I'm just gonna put 3 there for now. Put that, and then so each one would need 1, 2, 3. So connect each one to that one. These would all, I'll make these all in their own, so that it'd be blue. Blue. 1. And then we can also because we should be available then. Right. That. But I want to pair it. Alright, so I'm gonna get like this. This will be a greater network. So I got how many? 3, 4, 5, 6, 7, 8, 9. I got 9. Let's write this down. 9 addresses. Alright. So far we got 9 addresses for this first network I'm thinking for. And this first network we're gonna say 66 dot. And how should I do my schema? Schema, so it'd be 0.0.1 slash. This should be, we're gonna say this is gonna be a 24 net, because just in case we always have to add more redundancy to this first net, we don't want to lose does that allow me to keep things simple by doing things like that? what is a bigger, hold on one second. So it's 254 usable addresses. And 30. We got 28, 26, 26, 2. That's 62 addresses in that span, and that'd be yeah, so that's how I think we'll start building that off of like that, maybe. Yeah, 62 should be. Maybe I gotta need that many links, but 14. What did I just figure? 9. So a 28 mask. 28 mask will work fine. All right. And each subnet. /28. This is 2.5, 2.5. Dot 248. Dummy. Correct myself there, so yeah. And let's save this along with our project here. Okay, that. So our first host, our first network, 66.0.0.1. It's going to be with a 20 mask. All this. So this is our first network. Okay, I'm gonna go for a second network. And that second network is gonna start right here at 16, right here. I don't think my thing like spaces. So this is our second network. And what's this? The next network is 660.0.0.32. It's our third network. This right here. Nope, that's right here. The next network, .48. There's our next network. And we're gonna, let me see, so that cover all the bases for now. For that little subnet range, I think it does. And I think we pretty much efficiently broken that down. And again, so that gives us, with the 28 mask, that gives us 14 hosts per network. So each one of these networks, we've broken down to only 14 hosts. So let's see. Each network has 14. 14. What should I name it? Uniquely UNIQU. QU. Uniquely addressed host IP addresses. All right. So each network has 14 uniquely addressed IP addresses. And these are the span of usable addresses. So in the first network, the first host will have 66.0.0.1, and the very last host on that network will have 660.0.0.14. We have our broadcast address, so our broadcast address for that network is 66.0.0.15, so which gives us the next available host address, and then the network is 66.0.0.16. And then we come down here, and obviously we have our next network. First available, yeah, okay. Very good. Very good. And we've been able to, yeah, so we've got everything broken down pretty well. Anybody have any questions on that? Why I did that? Probably not. Sounds good. All right, so save this. Drop that down. Very useful thing I made today. I like it. Come here. That's big enough for me to see, right? You guys probably can't see too well, so I'm gonna do this. Change the host name and everything else. So okay. That's right. The next logical thing. So we're also we're gonna set up ether channels. So to set up ether channels so we can load balance over multiple links, we're going to we're gonna create ports and then assign interfaces, a range of interfaces to those ports to help load balance traffic over the network. And that's why we're using multi-layer switches. So we have we can load balance traffic through a backbone network, so everything's going to be pretty much like cycling through. You'll see that way we can handle a bigger flow of traffic, and potentially you can load balance it through the multiple interfaces on each port. You know, when you set them up like a port, it's like one logical channel but has multiple interfaces, so you can load balance that traffic. And there's multiple ways to load balance that too. We're going to use through IP addressing to see how it maps out and how it figures itself out and whatnot. So let's just run a couple of show commands so we can see what we got going on these switches here. Here's a list of our interfaces. So we have 24 usable gigabit ether interfaces. These other interfaces right here on this switch here relates to these. Oh, you guys can't see that. No, move that out of the way. Can't move that. But it relates to these four right here. Go back here. So we got 24, and come back here. Let's actually bring that back up. We can do this. This one, we'll erase it. So we're gonna work off of this guy first. This is gonna be pretty much the backbone. These will also be backbone, but redundancy. Pretty much like redundant with another. These almost be like edge, provider edge. That's what I'm thinking with these ones. These would be provider edge routers that have multiple single port interfaces that can be supplied with publicly facing addresses that can be used by whoever buys our internet, buys into our network here, so we can move data around for them. This is where I'm going to be starting off first. So this will be provider edge. And this will be backbone redundant. So BRs. This will be BB. So BR, BBP. All right, just have my labeling right. This will be the first network out, and this will be area 0. Let me label that too as well. Yeah, because no, just think it. There you go. So this would be backbone. OSPF, backbone, area 0. Okay. BGP. Now what should we use as an ASN number? Usually when you do this, but there's a private range, and we're going to use a private range, I guess, to just make this between us. But then we can use a public range when we get out. So we're going to use this then. So BGP public, we'll have to specify that public. ASN number, and this is going to be area 655.0.0.1. All right, and this, because this is going to be, let me start building this now. So this is going to be ASP area 1 PB W -1 and OSPF. So their loopback address is going to be 1.1.1.1. Router ID 1.1.1.1. And the network, complete network that OSPF is going to be looking at 66.0.0.0. That's going to be 25.0.0.0. Perfect. That covers this whole 66 network here. RID 0. Should I just be encompassing that area? See how this works as we go along. And so that's that. That's going to be our BGP with this router, for this switch, I mean. And then we're going to advertise network 1.1.1.1 at mask 255.255.255. And then neighbors. Now we're gonna have other neighbors, but we'll maybe set that up as we go along. All right, so it's looking good. All right, so let's get into this here. So the first thing I want to do is to create a port channel. So interface range, looks like gigabit. How many have we got? And we're going to use, let's go back to this one. It's going to be 9 in total. I got access to 24. So if we do the math, it's 2 each. Which is fine, and it leaves us pretty much 1 left over. That's fine. Because we're also, yeah, that's fine. All right, let me just take a look back at that. Or should I just go that other way? It's kind of limited on that. I've only broken it out into 4. I have to break it down into 9. So I did 3. Yeah, that's a better idea. So we'll do 1, 2, 3. And then each one of these. Yeah, that'd be good. What I'm gonna do is, you'll see. Alright, so we're gonna go back, we're gonna create a range. We're only gonna use 3, so do that. So I think that'd be better. So if we do 24 divided by 3. That gives us 8. 8 links. Let's only do we'll do 6. We'll do 6 each. Each port channel. Okay. So 6 links per. So we're gonna do 6 links. 1, 2, 3, 4, 5, 6, and then 7 to 12. and well, 7 through 12, and then 13 through 18. 13 through 18. And that leaves another, what's that? 1, 2, 3, 6 links left over, just in case we gotta add more redundancy to it. So it'd be 1 -0 -0, where, no, it'd be 1, right? Yep. Through gigabit, well, it'd be through 6. I believe he is just the last number. Then we're gonna say, actually, before we do that, we have to initialize that. So IP routing. Okay, so that's this. No, switch port, channel, channel group. And we're gonna say this is gonna be group 1. Channel group 1, mode, and what have we got? Active. Additionally, right, we're gonna go active. And that creates our first port channel. Pretty much like it's like an interface all on its own. Now we can go into that port channel, so port channel 1, and we can assign IP addressing and stuff like that to it. So we're gonna say IP address, and if we go back to our notes here, so our first one is first usable address is that right there. We're gonna use that. So 255.240. And what else am I forgetting to do? I'm gonna add a description to that as well. Add some good descriptions here today. Each link should node it to it. Alright, so this is our description, and we're going to say this is to BR. Switch 1. Say switch 10. We don't get confused here. Say his loopback address is going to be 10. IP. And his is probably going to be 6. 66.0.0.2. That next interface is going to be in 65502. Right. Okay. That looks good. Okay, we're gonna shut this down. Oh, we'll pull it up. Oh, we don't have to go back and redo it afterwards. Let's do a do. That's down. But that'll come up once there's traffic on it. All right, so we got our first port group set up. And we're gonna set up our second port group. Well, let's do our loopback address. Let's get our loopback address. Loopback 0. And we're gonna say IP address 1.1.1.1.255.255.255. Okay. Now we're gonna do our second port group here. So interface gigabit 1. So now we're gonna go from 7 to 12, right? 1, 2, 3, 4, 5, 6, 7, 12. 0-7 to 12. All right, we're gonna say no switch port, and we're gonna say channel group. And we're gonna name this channel group 2. Mode active. We'll create our second port group. All right, let's go into that port group now. And we're gonna say IP address on this one. What's next? Our second network. And we're gonna say this is, I'm gonna initialize assigned with an asterisk, 3 asterisks for assigned. And our next one is 660017. Okay. So 66.0.0.17. That's gonna be 255.255.255.240. All right. And we're gonna asterisk that for assigned. Need a description. So this description is going to be going to 20. Yep, that's right. And we're gonna give that a loopback address of say 20. Just keep it simple, stupid. And that's going to be at address 18. give this a no shot. Alright, now let's create our next port group. Again, that's from gigabit 10 -13 to gigabit 1. Oh wait, that's 18, right? Yep, 18. I'm gonna say no switch port. And we're gonna say channel group. We're gonna say 3 mode active. I'm gonna log into that now. IP address. And this is the third network here. And the first address is 6633. 255.255.240. Give that description. Just make sure we remind ourselves we've assigned ourselves that address. And that's going to be on a switch 30. Same thing, 30. And that next address will be 34. Okay. Let's do a no shut on that as well. And let's save that. And we have our port groups. So we have our port channel here. Their IP addresses, all in the respected IP network ranges, so we're not stepping on each other's toes here. But everything's pretty consistent with the flow. And then we have our loopback address here. So we've got that. What's next in our... that's the that's what I was looking for. Each port channel should load balance over IP. Alright, let's add this to each one of our port channel configurations. Done. that's done. So we got load balancing over sourced to destination IP. We're gonna do what's next? What's next? What's next? We should configure a spanning tree as well for rapid PTSD. Let's just exit out of this configuration mode. And I'll go back in. So we're gonna say spanning mode rapid. Which should be configured with cool. And what else? What else are we missing? Or no, I think that's kind of it. So let's do OSPF process ID 1. I'm going to say our router ID. It's going to be 1.1.1.1. And the network. So the backbone area network. I wonder if I should just keep it small. How would I write 240 as a wildcard address? Just gonna look that up real quick. All right. You know what we'll kind of say? To keep things simple with this, so we'll say 66.0.0 .0 to encompass that, but we'll do 0.0.0 .245 to cover only the network that goes up to here, and we'll say that's area so we can do either as IG or decimals. We'll do decimals. So this will be area 0. Got that. All right. Now if we go into, because I think that covers our OSPF configuration for now. At least. So if we go over to router BGP, and we're gonna say 65501 as our ASN number, and we're going to advertise network 1.1.1.1 at 255.255. Network mask. Forgot the mask. Ugh. All right, and we're gonna know our neighbors because, yeah, so if we do a do show run section interface, we already know some of our addressing for some of our neighbors here that we've kind of, yeah, so that's going to be one of our neighbors, that's going to be one of our neighbors, and that's going to be one of our neighbors. That's why I went ahead and did that, and that's where they're going to be located too. So if we come over here in BGP and we say neighbor, and this is IP address, so we're going to say 66.0.0.2 and remote area 65502. And then 18 is going to be in the same one, and then 34. Alright, so let's do. There is our OSPF configuration, route ID, and then the network. Perfect. That thing's still exploding on itself. Alright, and let's do this. BGP. Looks good. Looks good, looks good. Oh, looks good. Let's do a complete make sure we get everything. Host name, good. Port channel, load balancing, rapid PBST. There's no IP, domain. Okay, yep. All ports, channels. Figured right. Yep, mode active, good. And we have good. Yeah, so our configuration looks solid on that, so let's save that. Save that. Let's minimize that for now. Minimize that for now. Let's come over here. Let's just give our project a quick save. We'll just shut down. Let's come back here and come over here. And then this is gonna be ISB. One BR SW10. Mm-hmm. Yeah, because I would have to change each and one of them. I would just have to. Okay. Let's do that. Let's see what kind of issues we'll run into. This. Come over here. I'm gonna copy. I'm gonna paste. I'm gonna name you 10 BR. All right, so for 10, all right, so this stuff right here. is the back's gonna be 10, 10, 10, 10. Gonna be area 1. No, he's gonna be in the same area. I did not do that. I did this. And then 2, 10, 10. No go over neighbors, whatnot. You're right over there. Yeah, okay. This is our new host name. Okay, so let's go into our loopback 0 interface. We're going to change that IP address now to 10. Let me just copy and paste. It's easier. This shit up. Okay, let's exit. And then we're gonna say no router BGP 65501. And then we're gonna say router BGP 65502. And we're gonna we need to router OSPF 1. Oh. Ten. Mm-hmm.
If my phone rings and it's charging, will you be able to hear it from the computer?
Yes.
Just making sure, 'cause waking up before 12.
Mm-hmm. Did she? Oh, baby, I'm glad I did it. You're good. Mm-hmm. That's our network. That's the 10.10 for our loopback address. And we're gonna know at least one of our neighbors. One of our neighbors is at. Yep. Yeah, because that's the first line going to where I'm at right now. So that'd be 660.0.1. And they're in 65501. It's not in the loop, it's different, dumbass. I think guys, it's still recognizing that it thinks it's still using that. Let's exit out of this. I'm just gonna figure out how to clear it. That thinks, yeah, I'm pretty sure. Then I'll copy these ones and it'll be easier for me to do that. I don't have to fight that. Or I just might have to recreate this all from scratch. Do it that way. Come on. I swear I broke ChatGPT's. Alright, you know what, we're good. We're gonna do this. I'm gonna delete this guy. And we're just gonna create a whole new one so we don't deal with that. And here we go. A whole new guy right here. Let me see. I'm not down with that. Over here. Geez. Power supply. That way I can also do the yeah, I could create the port groups and stuff like that without having to assign IP addresses and stuff like that, so it doesn't look, so everything's not all messed up. So could figure a base model here. We'll say host and your ISB 1.br SW. So, guess what would be the basic configuration here for these guys? It would just be setting up the port channels. Yeah, it'd be setting up the port channels. Okay, so we're gonna do that for this. So we're simply just gonna do interface range, and that's gigabit. Zero dash 126. I'll switch port. Channel group mode. Oh, channel group 1. Yeah, because each one of these was gonna have a 1. Well, each one of these is gonna actually have 4. Yeah, each one of these is gonna have 4. Okay. Oh, are you okay? Holy fuck. Alright, we're gonna say 12 us. Not 12. This is from 7 to 12, yeah. 7 to 12. Switchboard. And this is group 2. And from 13 to 18. This will be group 3. And one more. So from 19 to 24. So we group 4. And now we should have all of these port groups to show IP. And we do. We have all of our port groups here. Now let's come here. Let's do this for each one of our port groups. Okay. And spanning tree. Oh, the only thing I'm not going to do, a couple things I'm not going to do. What's that? Okay. Don't want to start messing things up here. And let's do a yeah, okay. port channels are set up here. What's happened here? Yeah, our port channels are messed up here. Alright, so I'm glad we caught that, because we gotta go back in there and fix that all. One dash 0 dash, what's that, 19? Yep, 19 to 24. No switch port. Uh-oh, what happened? Alright, so we're gonna do this for us. No channel group 4. Cool. Alright, so that fixes that. And now, since we're gonna do the no switch port. Now we'll do our channel group. Hey, mamma mia. Hey, so so I've erased my channel port. Let's go back into the range of interfaces. Gigabit 10 dash 0 dash 19 through 24. Okay, now switch port. Just to do it again. Channel group or mode active. Okay. We have our port groups. Correct. Correct. Alright, glad we caught that. So, good. We got all that. Did we do a loopback address? No. We didn't do that because that's going to change from switch to switch to switch. But that's all set. That looks good. Alright, so this will be like our base then. How's that? Cooking it up.
No problem.
All of our ports. Cool. Link on each one of these. And we've already kind of given us an IP address for that. And then remember we have to manage port channels too. So port 1. So that is our port 1 right there. Damn, that does it for port 1. Because there's a port 1 there, and there's a port 1 there. I can always delete them. So if we connect, so confusing. But I did make available 4, so connect 1 right there. Still can connect 1. And if I use 2 there, I can use, no, I can't use 2 there. I have to use 2 here. And then 3, and then I could use 2, connect the 1, and then I can connect 3 here since 2 would be using there. And I can use 2 there. Those connect there. That. Still have available. I have. Leaves me with port 1 available on that. Port 1 available on that. And port 2 available on